And now we've got 3 variables. The process is going to remain the same, it's just going to be longer. So I'm going to multiply both sides by 3 and kill that fraction. So this becomes 3x plus 6y plus 3z equals 8. So that's going to be my new matrix. Our augmented matrix, 1x, 1y, no z, equals 1. 2x minus 1y, 1y, plus 1z equals 1. 3x plus 6y plus 3z equals 8. Now what I normally do, especially once I get into 3 by 3s, because I can make mistakes so easily on the 3s, I go down the columns. 1x, 2x, 3x, 1y, negative 1y, 6y, 0z, 1z, 3z, 1, 8. Looks like I've got the matrix correct. So if I do it in rows, then I check it in columns. Now I have to have a strategy. There's the main diagonal. I need zeros in 3 places. Here, here, and here, because we're going to put it in upper triangular form. This 1 is going to kill the 2 and the 3. Once that happens, I'm going to move over and down 1. Whatever is here is going to kill that 6. Because remember, I need to have a 0, a 0, and a 0. So I'm going to use the top of column 1 to clear column 1. I'm going to use the second row of column 2 to clear column 2. If I had more, I'd move over here and down. So I know what my goal is. So in order to do that, and once you move, well, no, never mind. So that says in order to get rid of that 2, I'm first going to need to take negative 2, multiply it times row 1, and add it to row 2 to give me a new row 2. And I'm going to need to take negative 3, multiply it times row 1, add it to row 3 to give me a new row 3. That puts zeros in these 2 positions. I use row 1 to clear column 1. I'll use row 2 to clear column 2. I'd use row 3 to clear column 3. So here we go. And I'm going to create a new matrix. The new matrix has a fixed row 1. But I'm going to do a new row 2 and a new row 3. Now I'm going to do a new row 2 by taking negative 2 times row 1, adding it to row 2. So negative 2 times row 1 is going to be negative 2, 0, negative 2. Add it to row 2. That's going to give me a new row 2. So row 2 is 2, negative 1, 1, 1, 0, negative 3, 1, negative 1. 0, negative 3, 1, negative 1. Now I'm going to create a new row 3 by taking negative 3, multiplying it times row 1, adding it to row 3 to give me a new row 3. So negative 3 times row 1, negative 3, negative 3, 0, negative 3, add it to row 3, 3, 6, 3, 8, get a new row 3, 0, 3, 3, 5, hopefully. And then I say, yippee! Because now I'm going to use that position in row 2 to clear column 2. What do you notice? If I add them directly, what happens?
Cancel out.
The 3's are going to go. So that says I'm going to create a new matrix. One, 1, 0, 1, 0, negative 3, 1, negative 1, and I need a new row 3. So I'm going to create a new row 3 by just taking row 2 plus row 3 equals my new row 3. So that row 2 is 0, negative 3, 1, negative 1, added to row 3, which is 0, 3, 3, 5. Oh, how cute is that? Gives me a new row 3, which is 0, 0, 4, 4. Is that not adorable? Now, if I go down the main diagonal, what do I have below it? All zeros. So I'm going to wind it back out. X plus y equals 1. Negative 3y plus z equals negative 1. 4z equals 4. That says z equals what? 1. Negative 3y plus 1 equals negative 1. Negative 3y, I don't like that, equals negative 2. Y equals 2/3. And, oh, that's not going to be too bad. And then we get that x plus y equals 1. X plus 2/3 equals 1. X equals 1 minus 2/3, which is 1/3.